Good day everyone. In this video, I am going to discuss the derivation for the standard equation of parabola with vertex at the origin. So let us consider this graph of parabola in the Cartesian plane where the vertex is located at the origin 0, 0. Then of course, based on the definition of parabola, it is set of all points in a plane that are equidistant to a fixed point and fixed line. So again, we have fixed point called the focus and fixed line called the directrix. So here, we consider first the focus, so F. So let's have F for the focus. And it is, let's consider it as P units above the vertex. So the coordinates of the focus will be 0, P. Yeah. And again, as I mentioned, based on the definition, the distance from the focus to the vertex is equal to the distance of the vertex from the directrix. So therefore, this point, say point A has coordinates, it is P units below the vertex, so it will have coordinates 0, P. Okay. Now we have here a point on the parabola, point P with coordinates x, y. Now let us consider another point, say point B. Let us determine the coordinates of point B. So here, we see that point A and point B are horizontally aligned. And if a point or if points are horizontally aligned, then their y coordinates are the same. So its y coordinate will be negative P. Now, considering point P and point B, they are vertically aligned. If two points are vertically aligned, their x coordinates are the same. So its x coordinate is x. So therefore, we identify the coordinates of the points that we will be using for the derivation of the equation of parabola. So the focus is located at 0, P, where P is the distance from the vertex to focus. And we have point A, the coordinates of which is 0, P. And then we have point P, which is x, y. And point B has coordinates x, P. And again, based on the definition of the parabola, all points, set of all points in a plane equidistant to a both fixed point and fixed line. So consider d sub 1 and d sub 2. So therefore, d sub 1 should be equal to, or definitely will be equal to d sub 2. Now, d sub 1 is the distance of point F to point P, or it is equal to the length of the segment FP. And d sub 2 is equal to the distance of point P to point B, or simply the length of the segment PB. Now let us get the distance of point F to point P using the distance formula. We all know the formula for the distance. It is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So again, we are looking for d sub 1. So for point F, so we have coordinates 0, P, and for point P, we have x, y. So substituting the values, we have x minus 0 squared plus y minus p squared. Okay? Simplifying this, so we have d sub 1 is equal to the square root of x minus 0 is x, squaring it is x squared. Plus, we have here, let's write it as y minus p, or the quantity of y minus p squared. Now, that is the distance of point f to point P, or that is the length of segment FP. Now let's proceed to the distance, or d sub 2. For d sub 2, we will be using the same formula, but this time we will consider points P and B. So let's solve. So that is x minus x squared plus we have y minus negative p. So y minus negative p will be y plus p squared. Okay? And we all know that subtracting an expression from the same expression would mean 0. So therefore, d sub 2 is simply equal to the square root of, so this will be 0, x minus x is 0, squaring it is 0. So we have the quantity of y plus p squared. So now, based again on the definition, d sub 1 is equal to d sub 2. So let's have that. So we have d sub 1 is equal to d sub 2. Our value for d sub 1, so let's get d sub 1. So d sub 1 is equal to x squared or square root of x squared plus y minus p squared. So it is equal to the value of d sub 2. And d sub 2 here is the square root of the quantity of y plus p squared. Okay? So let's write it correctly first. Okay. Now, solving this radical equation, since both sides of the equation has a square root or radical symbol, we can just square both sides of the equation to eliminate that. Recall that we have the property the nth root of a raised to n is equal to the quantity of the nth root of a raised to n is simply equal to a. That is, whenever the index is equal to the exponent, the answer will be the expression inside the radical symbol or the radicand itself. So we only have x squared plus the quantity of y minus p squared equal. So here we are to cancel it out. So the answer will be y plus p squared. Now we are to expand both binomials. So we have x squared plus, so we have the quantity of y minus p squared. Squaring the first term, so that's y squared, twice the product of the first and the second. So we have y times negative p, that's negative py times 2, negative 2py. And squaring the last term, so we have negative p squared, so that is positive p squared, equals. So here we have again y squared. Y times p is py times 2, that is 2py. And squaring the last term, so it's positive p squared or plus p squared. Here, we can cancel out terms. So p squared will be cancelled out because they have the same term. If one is to be transposed to the other side, it will be cancelled out. Or we simply make use of the subtraction property of equality, subtracting p squared from both sides of the equation, so that will be cancelled out. Same with y squared and y squared. So the only remaining terms are x squared minus 2py equals 2py. And solving for x squared, so x squared equals 2py, transposing negative 2py, it will become positive 2py. And simplifying this, since they are similar terms, we can just combine them. 2py plus 2py is equal to 4py. And that's it. This is what we call the standard equation of a parabola that has vertex at 0, 0, and this parabola opens upward. So this will be our basis for the different types of parabola. Those parabolas that opens to the left, to the right, and that opens downwards. So that will have, our parabola will have different equations based on its orientation, which will be discussed further in this lesson. So that's it. Again, this is our equation. X squared equals 4py.